You've probably heard someone say heartbreak isn't real pain, that it's emotional, that it's in your head. They're wrong. In 2011, researchers at the University of Michigan put people who had just been through a breakup into an fMRI machine. They showed them a photo of their ex. And then they did something else. They applied actual heat to the subject's arms. Physical pain. The same regions of the brain lit up for both. Your brain does not distinguish between the end of a relationship and being burned. So if you've ever felt like a breakup was going to kill you, your nervous system wasn't being dramatic. It was telling you the truth. To understand why heartbreak hurts, you have to understand what love does to your brain first. When you're with someone you love, or even just thinking about them, your brain releases a cocktail of neurochemicals. Dopamine, oxytocin, norepinephrine. Dopamine is the one most people have heard of. It's associated with pleasure and reward. But here's what most people don't know. Dopamine isn't actually the chemical of pleasure. It's the chemical of wanting, of anticipation, of craving. When you're in love, your brain's dopamine system is in overdrive. You're not just happy, you're addicted. Every text, every glance, every moment with that person triggers a release. Your brain starts to map that person as a source of reward. Not just someone you like, a neurological necessity. Then there's oxytocin, sometimes called the bonding hormone, released during physical touch, eye contact, deep conversation. Over time, it literally rewires how your brain processes that person. They become woven into your sense of safety, comfort, and belonging. And norepinephrine, the same chemical that spikes when you're in danger. Heart pounding, heightened alertness, hyperfocus. In the context of early love, your nervous system treats your partner like the most important thing in the environment. All of this is happening below the level of conscious thought. You don't choose to feel this way. Your brain just does it. So when the relationship ends, when the source of all that neurochemical reward suddenly disappears, it's not just sad. It's a system crash. Withdrawal. That's not a metaphor. Researchers at Rutgers University, led by anthropologist Helen Fisher, have studied the brains of people who have just been rejected by romantic partners. The pattern they found in the brain activity was nearly identical to the pattern seen in people withdrawing from cocaine. Your brain had adapted to receiving that person. It had reorganized itself around them. And now that input is gone, your brain doesn't know what to do. The reward circuits that were firing constantly are now starved. This is why you feel that specific, horrible combination after a breakup. The obsessive thoughts. You can't stop thinking about them. That's your dopamine system, desperately searching for the reward it was trained to expect. The physical ache in your chest. That's real muscular tension, triggered by emotional stress signals from your brain. The inability to eat or sleep properly. Your nervous system is in a dysregulated state, cortisol elevated, your normal homeostasis disrupted. The feeling of not being able to breathe sometimes. Your vagus nerve, which regulates your heart rate and breathing, is directly affected by emotional pain. None of this is weakness. None of this is you being too sensitive. This is your biology doing exactly what it was designed to do. It just wasn't designed for the modern world, where you can break up with someone over text and then spend the next 6 months seeing their perfectly curated life on Instagram. Let's talk about that chest pain, because a lot of people describe it and don't know why it happens. There's actually a documented medical condition called Takotsubo cardiomyopathy, also known as broken heart syndrome. It's a temporary weakening of the heart muscle that can be triggered by severe emotional stress. It mimics the symptoms of a heart attack. It's real. It shows up on EKGs and echocardiograms. It's relatively rare, but it proves a point: emotional pain is not just in your head. It has measurable physical effects on your cardiovascular system. More commonly, the chest pain people feel is related to the autonomic nervous system. When your brain perceives a significant threat, and social rejection is a significant threat, evolutionarily it activates the stress response. Your sympathetic nervous system kicks in. Cortisol and adrenaline spike. Muscles tense, including those in your chest and diaphragm. The result is that tight, heavy, sometimes sharp sensation right behind your sternum. There's also a neurological overlap worth understanding here. The same neural pathway that processes physical pain, the anterior cingulate cortex, is activated by social exclusion, which makes evolutionary sense. For most of human history, being rejected by your group meant death. Being cast out, being left alone in an environment where lone survival was nearly impossible. Your brain evolved to treat social rejection as a genuine survival threat because for hundreds of thousands of years, it was. The relationship ended. Your nervous system thinks you might die. That's the mismatch between modern life and ancient biology. Not all heartbreaks are equal. And that's not just anecdote. There's neuroscience behind why some breakups shatter you, while others feel like mild sadness that passes in a week. Several factors determine the intensity, the length and depth of the relationship. The longer you are together, the more your brain has integrated that person into its neural architecture. More memories, more shared neural pathways, more rewiring that now has to be undone. How it ended. Sudden, unexpected endings are harder on the brain than anticipated ones. When there's no warning, your nervous system has no time to prepare. There's no tapering of the neurochemical dependency, it's a cliff, not a slope. Attachment style. This is one of the most significant variables. People with anxious attachment styles who tend to feel hypervigilant about relationship security experience, more intense activation of the brain's threat systems during rejection. Their nervous systems are already tuned to watch for signs of abandonment. When it actually happens, the response can be overwhelming. People with secure attachment don't feel less pain, but their nervous systems recover more efficiently. They have a more stable internal baseline to return to. Whether you saw them after, this one is crucial. Every time you see your ex after a breakup in person or even on social media, you're re-exposing yourself to the stimulus your brain associates with reward. Each encounter re-stimulates the dopamine craving. It's the neurological equivalent of taking one sip of alcohol during detox. The no-contact advice isn't just self-help wisdom. It's neuroscience. Your brain needs the absence to adapt. Let's talk about that specific agony. Opening Instagram at 2 a.m., checking if they've posted, looking at who they've been tagged with, analyzing the timestamp of when they last came online. You know it's hurting you. You do it anyway. This is not irrationality. This is a textbook variable reward loop, the same mechanism that makes slot machines so addictive. Skinner discovered that the most effective way to condition a behavior is not to reward it every time, but to reward it unpredictably. Random, intermittent reinforcement creates the strongest, most compulsive behaviors. In a relationship, especially one with any instability or inconsistency, you are likely already on this schedule. Sometimes they texted back immediately. Sometimes hours went by. Sometimes they were warm and present. Sometimes distant. Your brain learned to keep checking because sometimes there was a reward and it never knew when. After the breakup, the behavior doesn't just stop because the relationship did. The neural loop is still running. Every time you check their profile and see something, a new photo, a like, a story view, your brain gets a tiny hit. Sometimes it's painful, but neurologically it's still input. It's still engagement with the stimulus, and your brain, still in withdrawal, takes it. This is why willpower alone rarely works. You're not fighting weakness. You're fighting a conditioned neural pathway that was built over months or years. The question everyone asks, but nobody wants to answer. Research by psychologist Guy Winch and others suggests that for most people, the acute phase of grief after a significant breakup lasts somewhere between 3 months and a year. The wide range reflects the variables we discussed: length of relationship, attachment style, level of integration. But here's what's actually happening during that time in the brain. Your prefrontal cortex, the rational executive part of your brain, is working to create a new narrative, a new understanding of your life that doesn't have that person at the center of it. This takes time because it's literally structural work. New neural connections being built, old associations being weakened through a process called synaptic pruning. This is why you often feel fine for a while, then suddenly it hits you again. The brain is not linear. It processes in layers. You might handle the day-to-day absence well, and then hear a song or smell something and a deep associative memory fires and you're back at the start. That's not regression. That's the brain doing its job, working through a different layer. There are also documented gender differences in how this process unfolds. Research by Craig Morris at Binghamton University found that women tend to report more intense pain immediately after a breakup, but recover more fully. Men report less immediate distress, but longer-lasting effects, often because they have fewer social outlets for processing the grief. Neither response is better. Both are just different architectures trying to handle the same system failure. So what do you do with all of this? First, stop fighting the pain as though it means something is wrong with you. It means your brain worked. You attached. You loved something. The pain is proportional to the significance. An absence that doesn't hurt wasn't really a presence. Second, understand that getting over it is a misleading frame. Your brain isn't erasing the person. It's building around them, creating new pathways that don't route through them as the source of everything. That takes time, and it takes new experiences, and it takes, most importantly, absence from the stimulus. Third, the behaviors that feel comforting in the short term, checking their profile, revisiting old messages, staying in contact as friends before you're actually ready, are pharmacologically counterproductive. They feel like relief. They function like relapse. Your brain built a dependency. Recovery follows the same principles as any other dependency. Distance, time, new inputs, new associations, slowly a new normal. You're not broken. You're not weak. You're not taking too long. You're a human nervous system doing one of the hardest things it knows how to do, rebuilding a version of yourself that doesn't have them at the center. And that's not nothing. If this video gave you a new way to understand what you've been feeling, subscribe. Every day we break down the science behind the things people feel but can't explain. Next time, we're looking at why your brain mistakes anxiety for love and why the most intense relationships are sometimes the most dangerous ones for your nervous system. That one might change how you look at every relationship you've ever had. Thank you.